So if we're talking about the thyroid hormone synthesis, the first step is that when your hypothalamus releases thyroid releasing hormone, it acts on the anterior pituitary gland, and that releases thyroid stimulating hormone. And then the thyroid stimulating hormone acts on the thyroid follicular cells to release T3 and T4. And you also have thyroid stimulating immunoglobulin that is released by the which may stimulate the thyroid follicular cells to release T3 T4, and this thyroid stimulating immunoglobulin is formed in Graves' disease. That is why you have high T3 T4 thyroid hormones in Graves' disease. So if we're looking at the synthesis of the thyroid hormone, the whole process begins with your first step is the iodine sodium symporter that is located in the thyroid follicular cells. And before that, I would like to mention that we also have the thyroid gland is basically made up of follicles. So the follicles are arranged in a circle just like that, and these are all your thyroid follicular cells. So this is your thyroid follicular cells, and in the center we have the colloid. So this whole picture is shown for your thyroid follicular cells, and this is the colloid, which is in the center of the thyroid gland. The first thing that happens is that the iodine sodium symporter transports one iodine and two sodium inside the thyroid follicular cells using an ATPase. This iodine then leaves the thyroid follicular cell to go into the lumen, and while it's going into the lumen, this is in the iodide form, right? So it is oxidized, it undergoes oxidation and forms iodine with I2 by the help of the enzyme thyroid peroxidase. Thyroid peroxidase has three functions. First is oxidation, next is organification and coupling that we will talk about later. So the next step in the whole synthesis pathway is that we have rough endoplasmic reticulum within the thyroid follicular cells, which forms thyroglobulin using tyrosine, and the thyroglobulin molecule right now only has tyrosine. This goes on again in the colloid in the follicular lumen, and the thyroglobulin molecule in the lumen now combines with the I2 that we just formed in the lumen, and they combine with the help of thyroid peroxidase. In the process is called organification, and they form thyroglobulin molecules with MIT and DIT. What happens is that the iodide, it links with the tyrosine molecule, and it so if we have MIT monoiodotyrosine, you have one iodine linked to tyrosine molecule, and if you have two iodine linked to tyrosine molecule, that is DIT. Now this whole thyroglobulin molecules, it undergoes coupling reaction. In again, the thyroid peroxidase plays an important role here, and it forms T3 T4. How does it form it? Is that the MIT, if it combines with DIT, it forms T3, and if the MIT combines with if the DIT combines with DIT, it forms T4. This thyroglobulin molecule with T3 T4 MIT and DIT is then endocytosed back into the thyroid follicular epithelial cells, and then the thyroglobulin molecule with the T3 T4 that we need undergoes proteolytic breakdown. That is, proteolytic enzymes break it down back into T3 T4 to be into T3 T4 that is to be released into the blood, and then the MIT and DIT are free, and the T3 T4 in the blood, that is in the circulation, they go on into the peripheral tissue. And we also know that the T3 is more active, potent form of thyroid hormone, so we need more of it. So when T4 enters your peripheral tissue, it is converted by 5-deiodinase into T3, and therefore we have more T3 now. And in the process of forming T3, it also forms reverse T3, which is the inactive form, and the T3 and the reverse T3 levels are higher in pregnancy, and with the OCP use, it is just like a metabolically inactive byproduct. And I'm sorry, its production for reverse T3 is increased by growth hormone and glucocorticoid, not pregnancy and OCP. So what happens is that the T3, it goes on into downstream thyroid function, and if we look here, the deiodinase also plays an important role in the recycling. So when we broke down the thyroglobulin molecule, we just needed the T3 T4. What happens to the MIT and DIT? The MIT and DIT therefore are broken down by deiodinase into tyrosine and iodine to be recycled, and so that can go on and form more T3 T4 hormones. And the drugs that are acting here is that propylthiouracil and methimazole, they inhibit thyroid peroxidase, and we also have some drugs that inhibit 5-deiodinase, that is propylthiouracil, beta blocker, glucocorticoid, and also ipodate, which is a contrast agent. It inhibits it. And we have perchlorate and pertecnate, which are competitive inhibitor for the iodine sodium symporter present in the follicular epithelial cells. And this is all we need to know about thyroid hormone synthesis.